Good morning, student. Today we are going to discuss what are the conditions for spin-spin coupling. Yesterday we said that what is meant by spin-spin coupling. Spin-spin coupling, in short, if we want to say, it is the splitting of a signal into multiplet due to the magnetic field of proton on which are present on another carbon atom. Now, what are the conditions? The minimum condition or the primary condition for splitting for spin-spin coupling is that coupling of proton take place only if two protons are separated by maximum of 3 bonds. For example, see here Ha, Hb and Sc proton. If we calculate distance from Ha to Hb, it is 3 bond distance, that is 1, 2, 3. Hb is also 3 bond away from Sc, 3, 4, 6. So we can say that Ha and Hb can couple with each other, Hb and Sc can couple with each other, but Ha and Sc cannot couple because they are separated by 6 bond distance. The proton on vicinal carbon atom can be coupled only if they are non-equivalent. For example, they see in a structure of ethyl chloride, this proton and these protons are non-equivalent, so they can couple. But if we see the structure of 1,2-dichloroethane, so this proton cannot couple because they are chemically equivalent proton. Geminal coupling is possible if protons are non-equivalent. Just see in this structure, proton Hb and Sc are present on same carbon atom, but they can couple because the environment of Hb is different than chemical environment of Sc. How we can say that? Just see here, this Cl is present in the plane of this hydrogen atom, while in Sc proton, Ha proton is present. If here is a Cl atom, then both proton are equivalent, but here is not a Cl atom, here is hydrogen. That's why chemical environment of this Sc is different than chemical environment of this Hb proton. Splitting of signal takes place in such a way that the chemical shift value does not changes. Means splitting does not change your del value in any manner. Multiplicity of peak is given by n plus 1. This is the important formula. Remember this formula, it is very much important, where n is number of coupling proton. If there are more than one group of non-equivalent proton are present on adjacent carbon atom, then multiplicity is given by m plus 1 multiplied by n plus 1 formula. Just we are going to see how this formula works. Just see the structure of this compound. In this structure, just see the chemical environment of Hb proton. On its right hand side there is Sc proton and there is 2 Ha proton. These protons are non-equivalent, so we can write multiplicity of Hb proton is given by formula m plus 1 n plus 1. Now m is the number of Ha proton, so there are 2 proton, so we write 2 here. N is number of Sc proton, there is only 1 proton here, so we write 1 here. 2 plus 1 is 3, 1 plus 1 is 2, 3 multiplied by 2 is equal to 6. So we can say that in your high resolution spectra, the Ch2 signal, let's consider it is Ch2 signal, this signal is split into 6 microsignal, 1, 2, 3, 4, 5, 6. This signal is splitted into 6 microsignal. But while splitting, if the del value in low resolution spectra is 4, so this splitting does not change that value. It is always remain 4 in your spectrum. Now the intensity ratio of multiplet, it is very important. It is calculated by the formula 1 plus x raised to the power n. This is the intensity ratio of multiplet, not your signal. So just seen in this example, we are calculating intensity ratio of Hb proton. Hb proton, to Hb proton there are 3 Ha proton is adjacent. So intensity ratio of Hb proton is equal to 1 plus x raised to the power 3, where n is number of proton coupling proton. So 3 proton can couple with this Hb because they are adjacent. Expand this formula. Expansion of this is 1 plus 3x plus 3x square plus x square. Remember that in this formula we have to take only coefficient. So intensity ratio of multiplet is 1:3:3:1. For example, for CH3 in low resolution spectrum, if we got this type of peak, so in high resolution spectra, this split is splitted into 4 equal half. For Hb proton, this peak is splitted into 4 equal half. This split is, for Hb proton, the signal is splitted into quadrant manner, and the intensity of this signal, that is splitting of this signal, take into 4 part, but while splitting it have 1:3:3:1 ratio. Means this peak, if it is 1 centimeter in your spectrum, so other peak should be 3 centimeter, onward is 3 centimeter, and this is 1 centimeter. Some proton like OH, COH and CHO undergo rapid exchange, so they do not undergo coupling. It is important. Alcoholic proton do not undergo any type of coupling. So in ethyl alcohol, we see that though CH2 is adjacent to your OH group, but this proton only gives singlet, and its singlet is not splitted. The coupling constant J is same for multiplets given by 2 coupling proton. We come, what is mean by coupling constant? Now it is important. The distance between adjacent peak in the multiplet, that is this distance which are present in your multiplet, it is simply known as coupling constant. It is denoted by capital J. Its unit is hertz. Unit is hertz. The J value of proton, which is the J value is exactly same in case of proton which is coupled with each other. The value of J is independent of applied magnetic field. This property of coupling can be used to distinguish between a doublet and two different peaks given by non-equivalent proton. What is this value helps in a spectrum? How this impact your spectrum? What information we can draw from J value? So just see the spectra of ethyl alcohol. This is this is the spectra of ethyl chloride, not alcohol. In this spectrum, see, we got two signal for first signal for CH3 and second signal for your CH2. The CH2 signal is splitted into quadrat and CH3 signal is splitted into triplet. The splitting of CH2 signal into quadrat is due to the 3 proton which are present on this carbon atom. And if we are going to measure distance between these two adjacent peak in a multiplet, this and this, it comes as a same. Let it is denoted by J dash. And same thing is happen in CH3. Let it is denoted by J. So these two are non-equivalent proton. HA and HB are non-equivalent. That's why J dash cannot equal to your J. What are the solvent used in NMR spectroscopy? Carbon disulfide, deuterated chloroform, it is CdCl3, deuterated benzene. What is deuterated benzene? All the hydrogen in benzene is replaced by your deuterium atom. Deuterated acetone. What is the information given by the NMR spectrum? Number of non-equivalent group of equivalent protons can easily be obtained. Means how many different groups basically present in your molecule. This can easily be seen by NMR spectrum. Position of peak gives the information about electronic environment of proton. What it means that position of peak of proton, the del value can simply tell us the proton is shielded or not, or it is de-shielded. From area under the peak, number of proton of any group can be calculated. Splitting pattern give information about number of adjacent proton. So we are now going to see all the points, how it is applied in NMR spectrum, that is application. So it is the most important part. So we are going to see how the NMR spectrum is read, or how the information from the NMR spectrum can be calculated. Let we take the molecule of ethyl bromide, CH3 CH2 Br. So first of all we have to find out how many signal this molecule give. So it is give two signal HA and HB. So we obtain two signal. Now next point is, what is the intensity of signal? That is intensity ratio. So it contains 3 proton and this group contains 2 proton and both are non-equivalent. So it is 3:2 ratio. After that we have to draw low resolution spectrum of NMR from this information. So this is the del and here is also del. One student can draw, we have to draw two signals, so someone can draw like this. This is the signal of TMS, it is always at 0, and any one student can draw it like this also. TMS, it is the rough spectrum. So first of all we have to decide which is the right rough spectrum. Out of these two, one is wrong. Why? That is, so always see here what is the intensity ratio tell us. Intensity is equal to 3:2. Okay. Now decide what is the effect of this bromine on this HB proton. This proton is deshielded. Deshielded proton got higher value, so it is the higher side signal. Since del value is here, it is the higher side signal. Since del value is higher here, because TMS is always have a signal at 0. Now see, in intensity ratio of this signal, 2 is for this CH2 and 3 is for this CH3. What it means that height of this signal should be less than this signal, while here we see that a signal which have higher del value, we write its signal higher. That is, this is the rough low resolution spectrum is wrong. This is the right low resolution spectra. Now we have to see how the splitting of Ch2 proton takes place. That is for this. What is the splitting pattern of this Ch2? That is Hb proton. So splitting of Ch2 signal. So formula is n+1. So where n is number of adjacent proton. How many proton is there? 3 proton is there. So 3 plus 1 is 4. That is quadrate. Now what is It simply means that this signal in high resolution spectrum is divided into 4 microsignal. Now next is, what is the intensity ratio of this quadrate? So it can be calculated from formula 1 plus x raised to the power n, where again n is number of adjacent proton. So it is 1 plus x raised to the power 3. So this is equal to 1 plus 3x plus 3x square plus x cube. So 1 is to 3 is to 3 is to 1 is the intensity of splitted Ch2. So now we are going to calculate splitting of Ch3 signal. So again formula is n plus 1. So adjacent number of proton is 2 plus 1. Adjacent number of proton here for this CH3 adjacent number of proton is 2. We write 2 here. So this is 3. So it is simply known as triplet. It means that this CH3 signal is splitted into 3 microsignal. Now how intensity is calculated? Intensity ratio of triplet, it is again 1 plus x raised to the power n. So n value is 2 here. 1 plus x is equal to 2. So we got 1 plus 2x plus x square. So split in pattern is 1 is to 2 is to 1. So we got all the parameters to draw the spectrum of your ethyl bromide. So how actual spectra look like, high resolution spectra? So see here, this is del is equal to 10. This is TMS. Here is, we write TMS, that is del is equal to 0. So we see this CH3 is splitted into triplet, that is signal of CH3 is splitted into triplet. So we can draw triplet and intensity ratio is 1 is to 2 is to 1. So this is 1, this is approximately double of this, and this is like it is near about this. Now how this signal is splitted? It is splitted into quadrate. And intensity ratio is 1 is to 3 is to 1. So it is 1. Near about it is 3 times of that. This is 3 times of that. And this is 3 times of that. Always remember, this is the intensity ratio of your signal. This is 1, 3 is to 3 is to 1. This is 1 is to 2 is to 1. When you split the peak of the signal, always try to make this CH3 peak higher, because intensity ratio is here for this peak is 3 while this is 2. Then further splitting is taking place. It is the intensity ratio of signal. Don't confuse it with intensity ratio of your multiplet. Both are two different things. So what is this distance? This distance in the multiplet in between two adjacent line. It is known as coupling constant. It is also coupling constant. J dash, let it is J, and they are not equal. J cannot equal to J dash. What is this distance is known as? Distance is basically known as chemical shift. Thank you very much.